All right, welcome everybody. Today we're going to talk about lesson number 44, and this is all about trig ratios in all of the four quadrants. So, just to kind of stop for a second, if you are not all caught up to date on the previous lessons and the previous homeworks, you might strongly want to consider going back and reviewing those before you go ahead and attempt lesson and homework number 44. Remember that for trig, more so than any other topic, it really is important that you're learning the lessons in the correct order. The end of the previous lesson was all about how to kind of name that quadrant, and that's really the focus of today. So if you need to review that material before we get started, feel free to go ahead and do so. So speaking of which, not only are there reference angles, which we've been talking about, remember that's the distance to the closest x-axis, which must be positive and acute, we're going to kind of extend upon that, and now we're going to use reference triangles. So you can see the two pictures in the top boxes here. They're really kind of saying the same thing visually, but because there's just different information, I decided to give you both. If you are going to draw a triangle, in one of the quadrants, you can only draw them in what I call the bow tie shape, meaning that your angle has to be the angle made with the origin. Lots of reasons why that's true. It goes mostly back to the fact of reference angles. Anything that would be true about the triangle in the first quadrant would also be true about a similar triangle in any quadrant, except for the positivity and negativity. And then there's a little bit of common sense. You're assuming that these triangles are made by taking the radius of a circle, starting in standard position, and then turning through some angle. Once you turn past 180, you no longer could even draw a triangle because it would be too big. So again, that's why you can only draw a triangle where the angle comes from the origin in one of these bow tie formations. So what we have here at the bottom two boxes, this is just reminding you of those 6 new trig ratios that I taught you last time, the circular trig ratios. And again, that's assuming that you're on some kind of a circle. On the left-hand box, you're assuming that there's a circle of any radius. Remember that the equation for a general circle is x squared plus y squared equals r squared. All you know for sure about that circle is that r must be positive. Remember, you can't have a circle with a negative radius. That just wouldn't make sense. So those are the 6 trig ratios. And again, pay attention to the 3 on the left and then their reciprocals on the right. Then notice that if you are in fact on the unit circle, you know 100% that not only is the radius positive, but it has to be exactly 1, which is why you can take all the ratios from the left side and then just turn all the r's into 1s. That means the equation of the unit circle is, of course, x squared plus y squared equals 1, and it just simplifies those ratios. The truth is, because r is positive in both of those instances, whatever you can say about the positivity and the negativity of any circle also is true about the unit circle. So what we have here is a catchphrase that people tend to use, or maybe calculus teachers tend to use, and that's all students take calculus. That's just meant to be a memory device for where the different trig functions are positive in the given quadrants. So take a look here at the setup on the left. So notice that, again, you're assuming that the radius of a circle moved through some movement from standard position, and then it stopped at some location. Wherever that location happened to be, you would drop a perpendicular and then create a triangle. The left to right distance would always be the x distance. The bottom to top distance would always be the y distance. And then you would be able to conclude whether those x and y values were positive or negative based on the quadrant. What the all students take calculus means is that in quadrant 1, because r is always positive and x and y are positive, if you were to calculate the 6 ratios, you'd be able to say that all 6 trig functions had to be positive, which is why they call that all. In the second quadrant, while the r and the y would have to be positive, the x would have to be negative. And again, that would be indicated by the fact that any point would be negative x, positive y. What that tells you is that any ratio that has an x in it has to be negative. So that would mean that the cosine, the secant, the tangent, and the cotangent would have to be negative, which would mean that only the sine and the cosecant could be positive in the second quadrant. In the third quadrant, again, while the r is always positive, the x and the y are both going to be negative. So again, if you look at the 6 trig functions, anybody who has just an x or just a y is going to be negative. because of the fact that the tangent has one of each. If you divide a negative by a negative, you get a positive, which means that only the tangent and the cotangent are positive in the third quadrant. And then finally, quadrant 4, again, R is always positive, X would be positive, and Y would be negative. So basically, anybody that has a Y in it would be negative, which means only the people with X's, the cosines, and the secant, those are the only ones that would be positive. So there's lots of different ways for you to remember that. You can remember the triangles. You can literally just draw it and use what you know about the quadrants, but the All Students Take Calculus is just meant to be a little bit of a memory device. The picture over here on the right, it really kind of says the same thing. It just gives you some slightly different values, some different positives, some negatives. So I just thought it might be helpful to kind of have both pictures. So at this point, you should be able to explain to me what quadrant are we in and why. So what would those problems look like? Well, let's take a look here. The terminal side of an angle, and that little a there is called an alpha. Again, just another variable they tend to use for trig. It passes through the points given below. Find the exact value of each of the 6 trig ratios. So alpha passes through the point 5, negative 3. The fact that it's the point 5, negative 3, that means that this is a quadrant 4 situation, since that's the only place where you can have a positive x and a negative y. I want you to kind of try to envision what is happening here. They're saying that in the coordinate plane, you have a circle. The circle has a radius of some value, and it's pointing towards standard position. Then it's going to turn through some angle, and then it's going to stop. Wherever the radius stops, you're going to go ahead and drop a perpendicular. That is going to create a right triangle. Remember that technically, even though you turned through this angle here, that angle is larger than 180, so you couldn't draw a triangle even if you wanted to. But really what we learned that because of reference angles, because of reference triangles, if we go ahead and put the angle alpha here, we're able to draw conclusions about this problem. So passing through the point 5, negative 3, the 5 has to be the x distance, which would be here. The negative 3 has to be the y distance, which is here. So again, what that tells us is that x has to be 5 and y has to be negative 3. Remember that the fact that you're on a circle, so center of 0, 0, which these are always going to be. So x squared plus y squared equals r squared. So 25 plus 9 equals r squared. 25 plus 9 is 34. To solve for r, you're going to take the square root of 34. Remember, normally when you take the square root of something, you would do plus or minus. But because of the fact that you're talking about a radius, it has to be positive 34. So x and y can be positive or negative, but a radius must always, always be positive. So once you have the x, the y, and the r, all they're asking you to do now is calculate the 6 ratios. So I'm going to find the sine of alpha, the cosine of alpha, and the tangent of alpha. If you need to refresh yourself on the ratios, remember that they're above, or you can try to just see if you can remember them. So the sine ratio is the y over the r. So that's negative 3 over the square root of 34, which would become negative 3 root 34 over 34. A cosine is an x over an r, so that would be 5 over the square root of 34, which would be 5 root 34 over 34. A tangent would be a y over an x, so a tangent would simply be negative 3/5. Then to find the other 3 trig functions, I'm going to say the cosecant of alpha, the secant of alpha, and the cotangent of alpha. Remember, you can go back and look at those ratios, or you can just remember that these 3 green ratios have to be the reciprocal of the purple ones. And if you're trying to do the reciprocal, it's easier to do them before you rationalize, or else you have to rationalize twice. So the cosecant is going to be negative square root of 34 over 3. Then the square root of 34 over 5, and negative 5/3. Remember, when it comes to positivity and negativity, you should either have the negative up top or you should have it out front. It's just not considered proper to put it in the denominator. And then here's where you just want to double check. So all students take calculus. you are in quadrant 4, which is the calculus quadrant. According to the phrase, only the cosine and its reciprocal, the secant, are supposed to be positive in quadrant 4. And if you double check, positive cosine, positive secant, and everything else is negative. And the truth is that's exactly what's supposed to happen. So let's go ahead and see if we can duplicate that process. If you're watching this on your own, maybe you can go ahead and pause and try it. So you are turning through some circle and you're going to go ahead and wind up through the point -3, -2. So the only way you can have a double negative is, of course, if you're in quadrant 3. So if you're in quadrant 3, remember some circle has a radius that gets turned through, and at some point you go ahead and stop in quadrant 3. You would go ahead and drop a perpendicular, which would create for you a right triangle. Remember, we don't really care about the angle that was turned through from standard position. We're going to use reference angles, reference triangles, and your alpha is going to wind up here. This tells us that the x is -3 and the y is -2. So we know -3 and -2. X squared plus y squared equals r squared. So 9 plus 4 equals r squared. Take the square root. Instead of plus or minus, it's always positive. So the square root of 13 is your r. Sine of alpha, cosine of alpha, and the tangent of alpha. So again, this is the square root of 13. So the sine, of course, is the y over the r. So -2 over the square root of 13, which would be -2 root 13 over 13. The cosine would be x over r. So -3 over root 13, -3 root 13 over 13. And the tangent would be the y over the x. So a -2 over a -3, of course, gives you a positive 2/3. So then cosecant, secant, and cotangent. Remember, the order that you put them in doesn't really matter, but I just always would recommend that whatever you start with, put its reciprocal, whatever you have in the middle, reciprocal, and same thing here. This is my preferred order. I know that above, for some reason, that starts with cosine. That just happened to be, the picture that I found on the internet, so no big deal there. Okay, so to find these ratios, remember, we're going to do the reciprocal, and of course, it's easier to do it before you rationalize. So I'm going to get -√13 over 2, -√13 over 3, followed by +3 over 2. Just as a reminder, all students take calculus. You are in the take quadrant, which according to the phrase means that the only things that should be positive are the tangent and the cotangent. And if you go ahead and check that out, it fulfills. So for this next set of problems, what they're ultimately asking you to find is the same as before. They ultimately want to know all 6 trig functions, but the way that the question is asked and the steps that you have to do to answer it are a little bit different. So suppose that the secant is equal to -3 over 2 and the tangent is greater than 0. Use this information to answer the following questions. In part A, we're again going to have to play name that quadrant. That's pretty much always going to be the first step for a lot of these problems going forward. Remember that generally each piece of information narrows down your choices by half. And just so you know, for no questions like this, will you actually wind up on the x or y axis, because you would not be able to draw a triangle in those circumstances. So starting with the fact that the secant of theta is equal to -3 over 2. So if the secant of theta equals -3 over 2, you'll want to go back or either try to remember what the ratio is, and that would be r over x. And again, just as a reminder, the reason why we know we're using these ratios is because nowhere does it tell us we're on the unit circle. None of the values have any of those pi's or any of those degrees. So unless you know for sure you're on the unit circle, you have to make sure you're using the ratios with the r. So if the secant of theta is equal to -3 over 2, and that's equal to r over x, then you have to be able to tell me what X is and R is. Remember that only one of them can be negative, and actually we know that it can never be the radius. So that's how we know that the R has to equal +3 and the X has to equal -2. Remember, when there's a negative out front, which is where it is, you can either assign it to the numerator or the denominator. And I know in this case that I'm actually going to assign it to the X because it wouldn't make sense to assign it to the radius. So now that I know that X is negative, that means that theta is to the left of the y-axis. So I know that I have to be to the left of the y-axis. And now I'm going to go ahead and use the second piece of information. So the second piece of the information is that the tangent of theta is greater than 0. So if the tangent of theta, which is equal to y over x, is greater than 0, and x equals -2, then we know that y has to also be negative because of the fact that the tangent is a y over an x, and because it winds up being positive, if the x is negative, that means that the y also has to be negative, which means that I have to be here in quadrant 3. So now that I know that I'm in quadrant 3, I'm going to go ahead and draw my triangle. So here in quadrant 3, I'm using theta, right triangle. What do I know so far? So I know that x is -2. I know that r is +3. I have to go ahead and find the length of that third side. So remember that x squared plus y squared equals r squared. So 4 plus y squared equals 9. Y squared is therefore going to be equal to 5. And in this case, when you take the square root, don't forget your plus or minus, and then you are going to choose plus or minus based on the quadrant. We are in the third quadrant, which means you have to have a negative y value. So all the information that you're writing for all the different pieces, it all has to coincide and make sense. And so far, everything looks good. So now that I know what X, Y, and R are, I'm perfectly ready to go ahead and create my ratios. So again, just to be clear, this is the X, the R, and the Y. So a sine is, of course, equal to a y over an r, so -5/3. A cosine would be an x over an r, so -2/3. A tangent would be a -√5 over a -2, which of course would turn out to be a +√5/2. Remember that for the other three, you're going to go ahead and do the reciprocal. So -3/5, which you will make -3/5/5. And then -3/2. And then 2/5, which becomes 2/5/5. If you have 3 different side lengths, which you do, you should always have 6 different ratios. And again, as a reminder, we're in quadrant 3, which is the tangent. All students take. The only things that should be positive are the tangent and the cotangent. Let's go ahead and try one more like that. And again, if you're watching this on your own, you could feel free to go ahead and pause and try it. Starting with the fact that the cosecant of alpha is equal to 7/3. So if the cosecant of alpha is equal to 7/3 and a cosecant is equal to an r over a y, the fact that they are both positive tells us that r is equal to +7 and y is equal to +3, and alpha terminates above the x-axis. The only 2 quadrants where the y's are positive are either going to be 1 or 2. Then we're going to go ahead and use our second piece of information, which is the fact that the cotangent is less than 0. So if the cotangent of alpha, and remember the cotangent is equal to x over y, is less than 0, and y is equal to positive 3, the only way that that can happen is if x is negative. So based on the two quadrants that are left, if the x has to be negative, that means that theta terminates in quadrant 2. So again, the first time I did it, it gave me either 1 or 2. Then the fact that x had to be negative is how I know that this is a quadrant 2 situation. You don't usually wind up in quadrant 1 that often because everything is positive, although it does happen. So over here, we're going to go ahead and draw a quadrant 2 triangle. What do we know so far? We know that r is equal to positive 7. We know that y is equal to positive 3. We know that x squared plus y squared is equal to r squared. So x squared plus 9 equals 49, which tells us that x squared is equal to 40, which means that x equals plus or minus the square root of 40. The fact that it's in the second quadrant is how I know that it has to be negative. And I'm going to go ahead and simplify. So the square root of 4 times the square root of 10. So x is equal to negative 2 radical 10. So the most important thing you need is not only what quadrant are you in, but you also have to know the 3 different values for x, r, and y. And now you're good to go ahead and do your ratios. So the sign, of course, is y over r, which in this case is going to be 3/7. Then negative 2 radical 10 over 7, followed by 3 over negative 2 radical 10, which becomes negative 3 radical 10 over 20. So multiply by radical 10 over 10, 3 radical 10 over 20. Yep, and you can't reduce any farther. So then for your other 3, remember to go ahead and just flip them. So 7 over 3, negative 7 over 2 radical 10, which would become negative 7 radical 10 over 20, followed by negative 2 radical 10 over 3. You are in quadrant 2, all students. You're in the students quadrant, which remember the S means that the only positive value should be the sine and the cosecant. Finally, as hard as it gets is something like this final one here. So the terminal side of an angle, and that B is called a beta. Again, another common variable when it comes to trig. It lies in quadrant 2. So look at that bonus. They told you where it is. And it has to be along the line 2x plus y equals 0. You're going to be asked to order the values, the sine, the tangent, and the cosecant from least to greatest. So just something to point out here is that they're only asking you to find these 3 things, so you don't have to find all 6, and then asking you to put them in order from the least to greatest. You could use a calculator to help you with those values. So here, because of the fact that they're telling you that 2x plus 5y equals 0, that you have to lie along that line, you want to go ahead and figure out what is the slope of that line. So in order to do that, you're going to subtract 2x. Then you're going to divide by 5. So y equals negative 2 over 5x, or negative and then 2 over 5x. If you go ahead and look at where the slope is, if you remember, of course, that a slope is the rise over the run, and basically the changes in y's over the changes in x. What that's telling you is that if you were to go ahead and draw that line, y equals negative 2/5, if you're talking about being in the second quadrant, you would draw a right triangle like such. Your beta would, of course, be here, always from the origin. And if a slope is a rise over a run, which is a change in y over a change in x, you know that the y distance has to be the 2 and the x distance has to be the 5. And then you would go ahead and assign the negative based on the quadrant. So if you're in quadrant 2, that would of course mean that the 5 has to be negative. Find the third side. So x squared, which would be 25, plus 4 is equal to r squared. R squared equals 29. And again, if you take the square root, it's going to be positive 29. So we now have our x, y, and r. Again, notice they only wanted certain quantities. So they wanted the sine. So the sine is equal to the y over the r. So 2 over the square root of 29, or 2 radical 29 over 29, followed by the tangent. A tangent is, of course, a y over an x, which would be negative 2/5. And then finally, a cosecant. And the cosecant is the reciprocal of the sine, which would be the square root of 29 over 2. And then basically, to order them from the least to the greatest, you would just have to calculate their decimal equivalents and put them in order. And just so you know, if you put them in order from the smallest to the largest, you would have the tangent first, followed by the sine, followed by the cosecant. Just kind of a fun way to make the question multi-step, but honestly, which one of them is the largest isn't really, super important to this type of question. So you should now know how to confidently draw and find ratios in all 4 quadrants. Remember, the All Students Take Calculus is just a memory device to assist you. So you can now go ahead and try homework 44. So thanks very much for tuning in, guys, and we will catch you next time.